massive supervolcano eruption, like the one under Yellowstone National Park in Wyoming. The European Science Foundation has released a 70-page report called Extreme Geohazards, Reducing the Disaster Risk and Increasing Resilience. It references the Yellowstone supervolcano. Now, Yellowstone's volcano doesn't look like some others because it's a caldera, or a crater. It's around ground level instead of towering into the clouds. But scientists say it covers a really enormous reserve of magma beneath the Earth's surface. We have a rendering of what scientists say this underneath that volcano, an ocean of molten rock, they tell us, that stretches for hundreds of miles. Of course, nobody needs to freak out right now at all. Scientists say there's only about a 10% chance of an eruption like this happening anytime this century. So there's a good chance you'll never see it. But 10%, I mean, that's not tiny. And the U.S. Geological Survey noted last year, even if Yellowstone does erupt, it could be a small incident, not some Armageddon type thing. Michio Kaku joins us now. He's a theoretical physicist, a professor, a best-selling author, and friend of the program. Give us some context on this, what we're talking about here.
Well, forget the image of Yogi Bear representing Yellowstone. We're talking about a sleeping Godzilla underneath Yellowstone that, if it erupts in a maximum eruption called Category 8, it could literally tear the guts out of the United States of America. Instead of having 50 states of the Union, we would only have 30 states of the Union. Now that's Category 8. This report looked at Category 7, which is much more likely once every 1,000 years rather than once every million years. That means in every century, there's a 10% chance that somewhere on the planet Earth there could be a supervolcanic Category 7 eruption. That's the danger.
You just talked about a volcano that could wipe out 20 states. How in the world is that possible?
Well, it's happened before. 2.1 million years ago, 1.3, and also 0.6 million years ago. We have the evidence of a gigantic eruption that is sufficient to tear the guts out of the US of A. So this report has to be taken seriously, but hey, don't sell the store, don't panic. We don't expect it to happen in our lifetime.
It's hard really to imagine this lake of lava that stretches hundreds of miles in all directions. How do we know that, and how do they read that?
Well, just 2 years ago, there was a scare, in fact. We actually began to measure the size of this lava hotspot, and it turned out to be twice as big as we previously thought. However, the good news is that it's not migrating, it's not moving. We see no indication whatsoever that a big one is coming. However, eventually the law of averages catches up to you. And this report singled out Mount Vesuvius outside Naples, Italy, outside Mexico City, and Yellowstone as 3 hotspots where a Category 7 volcanic eruption could indeed take place in this century.
So there are only 3 of this size in all the world?
Well, there's several in Indonesia and New Zealand that have had Category 8 eruptions, in fact. But then again, we're talking about once every million years for Category 8. Category 7 will be many times the size of Mount St. Helens, enough to cause widespread destruction across the state, but not enough to destroy the US of A. But still something that we have to take very seriously now.
What would we get in the way of warnings, Michio?
Well, unlike a meteor from outer space, where you get no warning whatsoever, we get warnings. If you've seen movies like Pompeii, you know that there are days, in fact weeks, of eruptions building up, grumbling inside, underneath the ground, near the pocket of lava. So there would be enough time, several weeks, in order to begin evacuation if and when such an unlikely event were to take place.
All right, Michio Kaku on the news deck. No time to panic, but interesting, very interesting. Thank you.
Ground deformation is near the Norris Geyser Basin, the hottest and most unstable thermal basin in the park.
Norris Geyser Basin is one of the most dynamic of the hydrothermal areas at Yellowstone. It's always changing. We're always noticing new things that are happening.
Just a few years ago, satellite images showed Yellowstone's greatest rise in this area. Recently, however, it's reversed its direction and is now subsiding.
It's not actually within the Yellowstone caldera, yet it's one of the highest temperature thermal areas in the park. And it is possible that there is some magma extending to the north beneath that region.
The source of the basin's volatility could be magma, or another key component to volcanic activity, earthquakes.
The earthquakes are essentially the heartbeat of the system, are an integral part of the active, if you wish, mountain building and volcanism of Yellowstone.
Like smoke and fire, volcanoes and earthquakes go hand in hand. The pressure from the magma, which can explode into a volcano, also forces the ground to shift, causing earthquakes. They can be the telltale signs of an impending eruption.
The two main precursors to a volcanic eruption, seismicity and ground deformation, are very carefully monitored in Yellowstone.
In this computer model, each red dot represents an earthquake. Typically, hundreds of earthquakes are detected across the park each year. In recent years, the greatest earthquake activity has been centered under two areas of the park.
Well, you can see we have earthquakes that are concentrated on the north side of Yellowstone, coming down through the park, and then out extending on the east side of the Teton Fault right here.
What concerns geologists is when a center of earthquake activity overlaps an area of shifting terrain. At the Norris Geyser Basin, that seems to be what's happening. There are dozens of fault lines at this spot.
That's very critical because if magma is starting to move up, we would expect to see a bulging in an area and associated earthquakes as the ground starts to crack.
The fear is faults that make up the earthquake zone could crack under pressure from the magma below, releasing an eruption. Geologists are also watching the park's geysers, hot springs, and mud pots, looking for drastic changes in temperatures and chemical content. Anything that might indicate a major movement of magma. At the moment, geologists do not believe an eruption is imminent. But if the water temperatures were to rise, the ground begin to swell, or there were an increase in earthquake activity, another Yellowstone eruption could be building.
I think that we are smart enough as geoscientists now that we would probably have weeks to perhaps months of indicators before anything like that would occur.
However, predicting the precise timing of an eruption is far from simple. Scientists have been fooled in the past.
We've seen it in Yellowstone. There's bulging, there's vibrations, there's increased seismicity. There's all the things one would expect and go, oh, uh-oh, we're in trouble. And then, nothing.
Supervolcanoes like Yellowstone could explode suddenly, without warning, without seismic movement signaled as earthquakes. When we think of an explosive volcanic eruption, we imagine it being preceded by earthquakes, by ground swelling, by the mountain venting some hot gas, perhaps even some lava. These are the signs we look for in the inexact science of volcanic predictions. But two research papers, published on the very same day this year, say that predicting supervolcano eruptions is even more difficult than predicting the eruptions of regular volcanoes. More on that in a moment, but first, do the events in Yellowstone earlier this year demonstrate changes that may be building toward an eruption?
We did have an earthquake of 4.8 magnitude. Now that is the largest we've had in Yellowstone in over 30 years.
And a couple of months later shuts down a road that's melted because of increased ground temperature. People start to get edgy about an impending eruption. I went to Yellowstone recently, and geothermal activity is everywhere. A reminder that you're on top of a super caldera and magma dome, the largest on Earth.
Frankly, we are just a few miles above some really hot magma. That magma serves as the heat that fuels the geysers and hot springs and fumaroles in the park. It's that engine that allows for the unique things that we see here in Yellowstone.
This is what the melted road looks like 2 months later. Yellowstone spokesman at the time said the road had turned to soup, and that was widely reported, even in the mainstream media. But when I spoke to a ranger there, she dismissed it as simply a bad asphalt job. It was closed due to melting, the heat?
No, no, it has nothing to do with that. That was just a couple of days. It was the asphalt was soft. It was actually a bad asphalt job that they had done the summer previous to that.
Okay.
And that combined with the intensity of the sun in the middle of the summer, and that it was in a hydrothermal area, that it just got soft.
Oh, okay.
And they just had to replace it.
So it had nothing to do with an increase in geothermal activity in that area, the ground being hotter. It was just the asphalt wasn't.
The asphalt, yeah, it was the combination of those things in that particular spot.
I hadn't visited Firehole Lake Drive when I spoke to her, or I would have challenged what she told me. 2 months later, the road still doesn't look good. But more importantly, Yellowstone spokesman told the press at the time that people needed to stay away from the road because there was a high danger of stepping on seemingly solid soil into severely hot water. Contrary to what she said, Firehole Lake is an active geothermal area, and you can see that the road deteriorates as it comes into proximity to geothermal features. But it's what we've come to expect from government employees at every level: fear for their job if controversy erupts, and contempt for the public's right to know. If it was just a bad asphalt job heated up by the sun rather than increased ground temperature, then why are there other melted paved areas that they've just fenced off rather than try to fix? My suspicion is that the spots are so hot at the moment that they can't fix them. Ground temperature goes up and down with seismic activity in the park.
We see between 1,000 and 3,000 earthquakes a year in Yellowstone. Most of them are so small, nobody ever feels them.
Swarms of small earthquakes that you can't even feel can cause the ground to go through major changes. Look at this area that was once a forest. The ground was a hospitable environment for trees to grow for a long period of time. Then in 1978, swarms of small earthquakes caused the ground in this area to rise to 200 degrees Fahrenheit. It wasn't the quakes, but the heat that killed the trees. So while we may be heading into another period of increased activity in Yellowstone, it's far from the largest activity we've seen since it became a park. Of course, everyone will tell you that it's not if, but when the super caldera blows up.
Yellowstone's supervolcano has been hit by a series of earthquakes, with more 30 recorded since June 12. The latest was recorded on Monday, June 19, with a magnitude 3 earthquake striking 8.6 miles north-northeast of West Yellowstone, Montana. The swarm began last week, and on June 15 saw a magnitude 4.5 earthquake take place in Yellowstone National Park. The epicenter of the shock was located in Yellowstone National Park, 8 miles north-northeast of the town of West Yellowstone, Montana. Scientists from the University of Utah, which monitors Yellowstone volcano, said in a statement. The earthquake was reportedly felt in the towns of West Yellowstone and Gardner, Montana, in Yellowstone National Park, and elsewhere in the surrounding region. This earthquake was the largest to have hit Yellowstone since March 30, 2014, when a magnitude 4.8 earthquake was recorded 18 miles to the east, near the Norris-Geyser Basin. The 4.5 earthquake is part of an energetic sequence of earthquakes in the same area that began on June 12. The statement continued. This sequence has included approximately 30 earthquakes of magnitude 2 and larger and 4 earthquakes of magnitude 3 and larger, including today's magnitude 4.5 event. As of June 16, 235 events had been recorded. Most of these ranged in the magnitude of 0 to 1, with 5 less than 0. The University of Utah is part of the Yellowstone Volcano Observatory, YVO, which monitors volcanic and earthquake activity in Yellowstone National Park. Seismic activity at volcanoes can signal an eruption is due to take place, although predicting exactly when a volcano will erupt is.
As you see, the calderas left by the magma plume at Yellowstone. So you can see that the Earth's crust has moved across this plume, and subsequent eruptions you can see moving further north as the crust moves in a different direction. The magma plume itself is not what anybody thought. Usually they don't tell us a whole lot about the magma plume, but it's not a ball of magma. And the magma plume is actually not traversing up vertically from depths. It is coming up at a lateral motion from Idaho, where it's deep, into Yellowstone, where it is getting very shallow. This is a diagram showing you where most of the earthquakes are occurring is in this blue zone, where the magma percolates, and it starts to separate out and become superficial, closer to the surface, different compositions. But when magma filters through cracks and then percolates back down, it hardens and forms these dikes. These dikes compartmentalize the underneath ground into chambers. The dikes have a tendency to crack and break and fill empty chambers, thereby creating an overflow system for the park itself. And it's not unusual to have new substance come up and form different dikes for different substances of different temperatures and different liquidity. The rhyolite, like I say, this is a rhyolite slab. That is really the big question mark as to how it will behave under this type of structure. These are cracks. They go deep into the ground. They look like honeycomb from the air. Magma fills and seeps in, and then the compartmentalized magma will create a much smaller crater inside the caldera itself. And this is an example of what we're hoping, if there's an eruption, will happen. It'll be a small eruption from one of these chambers. Long Valley is a different story altogether. The central magma chamber is creating all the uplift in this area. It's a central resurgent dome. We don't want that to go. But this explains why Yellowstone is so well behaved. Notice, though, the cylinder is a diagram showing what happens in the convection zone, where there's a lot of churning liquid magma, foaming magma, and water. You get a positive and a negative polarity between the colder and the hotter barriers and boundaries, and that's what gives rise to some of the electromagnetic events that you see surrounding volcanoes and even some seismic earthquakes that do occur in volcanic zones, because we know that seismic zones and volcanism go hand in hand. But this is a really nice structure, really, for notice the rhyolitic magma on the top, and notice at the edges of the caldera is where we have our intrusions. This intrusion spreads out laterally and flattens out. It's not very deep at the 2 kilometer depth. It's rather shallow. That's the rhyolite keeping it down. Don't let ash fields discourage you here. Even in the 600,000 year ago eruption, the tectonic plates and the shifting of the crust has placed things in a completely different arrangement than they were back then. Even the jet stream has changed. So we're predicting a left to right or east to west.
Okay, there's a lot of seismometers placed all around the caldera, and they're just measuring devices. The geology of this area is pretty complex, but the thing to notice is there are some fault zones that go near the surface. This is the part that they're targeting. The thing is, with this huge amount of high-pressure magma, if there is ever a breakthrough to the surface, you're going to have a major eruption. And it is just a tiny, tiny crack in the rock, what they call a tornillo, where you have a magma intrusion and then a flow, and once that reaches the surface, basically it's unstoppable. So what kind of thing are they doing here? Here's the fault zone that's been under attack for 2 years. This is dang it, I forget the name of that. They made all 3 of these. They're attacking 3 sites, and they've got like Maple Lake, Mirror, I forget, darn it. Anyway, this is the equipment, or it's something similar to the equipment they're using. They have a computer-controlled array of this type of device. It's called a vibro-sized truck. This is a 60-ton truck that can press this steel plate down and produce actually earthquakes. And when they're arranged in an array, you have the ability to put these pressure waves into the earth, which I'll show in a minute. And yes, they're absolutely huge. They're used for natural gas exploration because you can actually map the underlying rock with these seismic waves. here's a vibrosize waveform, and just a typical thump on the ground and the kind of thing that happens, and it looks like it's peaking about 10,000 pound force here. And here's one that's actually frequency swept. You want to remember, this is the kind of a waveform that can.
That no, it's happening every 100,000 or so. And satellites show us giant craters all over the world that have just been filled in with water or filled in with trees, filled in with foliage. I don't know all the mysteries of the universe, but I know this: the ring of fire from the Pacific Ocean all the way around from Asia to the tip of Chile has triggered everywhere in the last decade but key plates off California. Now, the sun's cooled off. That affects our climate. Is that doing it? Is it the magnetic field? He's the expert because he looks at all the studies, the full spectrum. So many experts at the university level just write their own little papers in their one little area and don't do the general research. He's with us for the rest of the hour, 5 minutes the next hour, standeo.com. And the last time he was on was over a year ago. Time flies, February 6, 2015. You can pull that interview up. You can hear it for yourself, but the body of his work's there, the books he's written. He has predicted things more accurately than anybody I have read or talked to. Here's the headline: Volcanic expert, super eruption coming. And now you see what they're calling unprecedented eruptions, unprecedented geological activity, tectonic activity. And going over his bio, he held an above top secret security clearance and worked undercover with the FBI. He was part of an exclusive black project specializing in the development of advanced technology. Stan's diverse background encompasses computer programming, marine architecture, advanced propulsion engineering, biblical studies, and earthquake forecasting. And I'm not going to go over all the things that he's breaking down, but we're going to get into earthquakes with him right now. Pretty wild stuff. Stan Deyo, great to have you with us. Thank you for joining us.
Thank you for inviting me again, Alex. There's certainly a lot happening to talk about.
Well, everything you said over a year ago here, I thought it was 6 months ago, is basically now happening. Tell us what's happening from your research, what's coming next, because obviously the government and people are going to play this now.
Well, there are probably good reasons for that. Not that I side with the illuminists. they have their own agenda, but the scientific community is hamstrung. And if they weren't, they have the fear of causing a panic if they predict an earthquake or a volcano and it doesn't happen. And so they're put in between a rock and a hard place to tell the public. And now then, of course, they've got a White House muzzle on them, so they can't say anything. I have gotten information out that is not mainstream or is not even on the internet from a couple of individuals who are involved inside USGS. And they have said that they've been making drivers, truck drivers, and technicians that are delivering stuff to USGS at Yellowstone, have been for the last 2 years, to not tell anybody about it, and the number of seismometers that they're putting in, and the fact that they're connected to a supercomputer. I think they've moved it from Texas now then to Utah, to the new center. But there's a lot of effort being pointed at Yellowstone, and you can see the evidence of it in a lot of the video coming out of there that they're allowing to come out. And also last month, toward the end of the month, they closed down the whole network of seismometers, updating and changing and whatever, but we got no feeds at that time from them. And Yellowstone is only one part of our problem. There are other